All right, let's jump right in. Today, we're talking about something called business action language, or BAL for short. It's this really cool way to write out complex business logic using plain, readable English. You don't even have to be a programmer to do it.
So, imagine you're running a business, right? Your promotions, your eligibility rules, your shipping policies, they're changing all the time. How do you keep your systems updated without having to call a developer for every single little tweak? Well, that is the exact problem BALWA was created to fix.
And here's the solution. BAL basically acts as a bridge. It lets the business experts, the people who actually know the rules inside and out, write them in a way that's structured enough for a computer to understand, but still perfectly clear for any human to read. It really gives you the best of both worlds. So here's our game plan for this explainer. We're going to cover the absolute core of BAL, starting with its simple if-then logic. Then we'll move into defining data, working with lists, and finally, we'll put it all together to build some really powerful rules. All right, first up, let's get into the absolute core, the very foundation of every single rule you'll ever write in BAL. It all boils down to a super simple two-part structure. That's it. Seriously, at its heart, BAL is really just a series of if this, then that statements. You set up a condition, and if that condition is met, you define what action should happen next. This simple pattern is the building block for absolutely everything else. And just look at how clear this is. There's no weird code, no confusing syntax, just plain English. If the customer is older than 18, then we mark them as eligible. Anyone, and I mean anyone, can read this and know exactly what it's supposed to do. Of course, life isn't always that simple. What happens if the if condition isn't true? For that, BAL gives us the else clause, which lets us define a default or an alternative action. And this is a perfect example, right? If a customer is a gold member, they get 10% off. Otherwise, everyone else gets 5%. It's a really clean and simple way to handle two different outcomes from a single condition. Okay, so a simple if-then is great, but to make our rules truly powerful, we need to build on that. We need to define our terms and create more complex logical tests. So, one of the best ways to make rules cleaner is by defining variables. It's super simple. You just start with the word definitions, then use set to give a kind of nickname to a piece of data. After that, you can use that simple nickname throughout the rest of your rule. Just look at this. Instead of having to type out a customer where the category of this customer is gold over and over again, we just define it once as preferred customer. This makes the rest of our rule so much shorter and way easier to read. So how do we actually build those if conditions? Well, we use these guys, comparison operators. These are the tools that let us test our data. Is a value equal to something? Is a number greater than another? You can think of these as the verbs of our conditional sentences. Sometimes one condition just isn't enough, and BAL has these incredibly readable ways to handle multiple tests. For an and check, you literally just say all of the following conditions are true. For an or, you say any of the following conditions is true. It's so much clearer than trying to read a long string of ands and ors, right? All right, so far, we've been talking about single pieces of data, like one customer's age. But what about when you're dealing with a list of things, like all the items in a shopping cart or all the transactions on an account? Let's see how BAL handles collections. BAL has a whole toolkit for this. We can count items. We can check if a certain type of item even exists. We can filter a list down to just the things we care about, and we can even perform an action on every single item in that list. Let's start with counting. The number of construct. Well, it does exactly what it sounds like. It lets you count how many things are in a list. And you can even add conditions to only count the items that match your specific criteria. And this is a fantastic example. See, we're not just counting all the items in the order. We are specifically counting the number of items where the price is more than 100. And only if that count is greater than 3 does the customer get a discount. It's so targeted and precise. Okay, but sometimes you don't need a full count. You just need a simple yes or no. Is this thing in the list at all? That's exactly what there exists is for. It's a simple true or false check. Does at least one item that matches my condition exist in this collection? Think about it. This is a perfect real-world scenario. If there's even one electronics item in that shopping cart, we've got to flag the whole thing for insurance. We don't care if there are 5 of them. The presence of just one is enough to trigger the action. Okay, We've learned the building blocks, the if-then logic, variables, comparisons, working with lists. Now for the really fun part. Let's put it all together and build a sophisticated, real-world business rule from scratch.
Just take a second and read this. At first glance, it might look a little complex, but it's built from everything we've just talked about. A customer gets gold status if they're over 18. And one of two other things is true. Either they've made more than 3 orders, or they've had at least one single order that was over $1,000.
The real power here is how it's all layered. We start with a simple age check. Then, inside that, we have this nested condition that looks at their order history in 2 different ways, using both account and that exists construct we just learned. All these little pieces work together to make one big, smart decision. So, let's wrap this up. What's the big takeaway here? BAL's real magic is its readability. It's all built on that simple if-then idea, but you can layer on variables, comparisons, and these really smart collection tools to build some seriously sophisticated rules, all by just combining simple, understandable parts. And that leaves us with one final thought. Think about a complex decision process in your own world. Maybe at work, maybe just in your life, approving a loan, calculating a shipping cost, heck, even deciding what to watch next. How would you write that down as a series of plain English if-then statements? It's a pretty powerful way to think, isn't it? Thanks for watching.